Now we're going to add the variance and standard deviation. So we saw standard deviation last class, but I didn't talk too much about what that means. What the variance and standard deviation are basically the values to see how differently most of these values are from one another. Are they kind of grouped together really tight, or are they separated out way far in a distribution? So here, if we want to find the variance, you would use this formula here, where you take your random variable minus the mean, and you square that quantity and then multiply it times the probability. That's how you would find your variance. And the symbol for that is sigma squared. The standard deviation that we've been looking at the last few days would just be the square root of the variance. So that's the formula we're going to be using right there. So on this particular problem, it says, here's our same distribution that we had from example 2 and 3. And the first thing we're going to do is find this front end of the value. So this is the random variable minus the mean, which if you remember, our mean was 2.4. So I'm going to take the random variable 1 and subtract 2.4 and square it. Whoops, let me undo that. So I take 1 and I'm going to minus 2.4 and then square that value. So we come over here, I have 1 minus 2.4 and I square that. I get 1.96. Now I'm going to do the same thing here. My new rating is now 2. My random variable is 2. We subtract 2.4, which would be negative 0.4, and we square that, which will be positive 1.6. It's 4 times 4 would be 16. So 0.4 times 0.4, actually, let me check that. That actually might be, I think I'm off. It needs to have, it's going to be 0.16. Yeah, there we go. Let's check that out, 0.16. By the way, the closer to 0, the more tightly bound the values are. So since this is closer to that 2.4, the numbers are a lot closer here. And now let's do the next one. And this one should be a middle value between the two. 3 minus 2.4 is 0.6. When you square that, we should get 0.36. So we can see these two are definitely the better variables. That one has the greater distance. So now to find our variance, what we're going to first do is find the same value we just calculated, the difference from the mean squared, and multiply it times the probability. So I'm going to take this 1.96. Let me actually start with the 0.16 since I have it there. I'm going to multiply it times its probability of occurring, which is 0.22. And for this middle value, I get 0.0352. All right, now I'll do it on the line above. We're going to take 1.96 and multiply that times the probability of 0.19. And I get the value 0.3724. And now for the last value, I'm going to take that 0.36 and multiply it times the probability of occurring, which is 0.59. And we now get here 0.2124. Okay, so now that I have these values, if I add them together, I should get my variance. The variance is the sum of these. So 0.3724 plus 0.0352 plus 0.2124. And I get a variance of 0.62. That's the variance right there, which is the sum of all these values. It's let me actually slide that over so I can write that. The sum of x minus mean squared times the probability of x equals the variance, which is 0.62. So if that's the variance, that would mean sigma, the standard deviation, would be the square root of that. So if I did the square root, SQRT, square root of 0.62, we get that this has a standard deviation of 0.782. 7.4 is what I'm going to do here. That would be my standard deviation. So I'm going to box these up. There's my variance and standard deviation. These symbols here are called sigma. All right, with that, I'll let you try, again, using the same data from your example 2 and example 3 guided practices. Use that same data, that same chart to come up with these values. And I've copied this on here, so if you need to pause the video to have your numbers together, you need to find your mean, and then from there, multiply through and get your variance and standard deviation. Pause the video if you need to.